Welcome to BizJet TV. My name is Fabrizio Poli. Today's episode is about vertical takeoff and landing. Lots to talk about this in the press. Lots of money, billions of dollars have flocked into this industry over the last 12 months during lockdown. So today we're going to be meeting with Matthew and Val, who are part of the team that created Ptero Dynamics, which is an interesting project here. It's got a very unique design. You'll be seeing footage of this thing flying. We're talking to them about, the whole development of the project and where it's going, certification, the first delivery, which is going to be happening a lot sooner than you may be thinking. So stick to this interview. Very interesting, worthwhile watching. And if you haven't subscribed to BizJet TV, I encourage you to subscribe to this channel. Give us a thumbs up. We'd love to hear from you after you've seen the video, your comments and what you think about this eVTOL market, the VTOL market. How is it going to go and how is it going to change the way we fly? So off we go. Okay. Welcome, Matthew and Val, to BizJet TV. Great to have you here today to talk to us about Ptero Dynamics, your vertical takeoff and landing project. So tell me a bit about your background, how you guys met, and how Ptero Dynamics started. Over to you, Matthew.
Well, I'll sort of just how we met, and then get Val, who's the founder and chief technology officer and inventor of this aircraft, sort of give you the fun story. But Val was introduced to me through a mutual friend in around late summer of 2017, and I saw a video of the aircraft fly. I knew instantly that it was going to be transformative to the business, and we kind of worked together just as a friend of a friend and helping as best I could. And the real pivot for me came in May of 2018 when we were at the Uber Elevate conference. Uber, the car company, and was at the center of the universe for the air taxi business at the time. And we decided to come out of stealth mode at that event, and we had the patent filed by that time, and the first patent, I should say, and we had the website just launched like the day before, and put our videos on YouTube, and we were kind of like the belle of the ball at that event. I mean, everybody wanted to talk to us. They were walking around, when they saw our shirt name, they're like, "Oh, show me the video of your flights," and so for me, that's when I really realized that all of these incredible, fantastic companies and air engineers really thought that this was something compelling, and that's when I became Val offered me the job to come on board as CEO, and I've been full-time CEO since then. So, but I think the story of how Val came up with the idea and how we got from there to here is really exciting. So I'll turn it over to you, Val.
Okay.
Yes. Thank you. Just kind of briefly how it happened. It started around 2016 when I was considering using what I would call a dihedral hinge with VTOL aircraft wing. And by 2017, I have figured out how to make the hinge robust and how to create a lightweight articulation system and put it all together on a small prototype. So once I flew the prototype, it flew so well at the very first flight. It was so responsive, so natural that I thought that this is something new. I filed for a patent and I registered the company for the purpose of commercializing this product. And that's really in a nutshell how it happened. A little later, I met Matthew, and as he discussed, offered him a position to be CEO, and off we went from 2018 until now. We slowly building our confidence in the systems, and we built several prototypes to show investors and to show other engineers that the concept is scalable and it is viable and it has great advantages.
Yeah, so let's talk about on your website, you talk about 7 different types of VTOL designs.
Sure.
So yours takes off like this, and then the wings fold out.
That's right.
A bit like Transformers. Let's call
Right.
it. Yeah, that's the way I see it, and probably a lot of people that are watching this, they see this thing transform.
That's right.
Off in the air.
There are 7. Right. So there is. I particularly personally view there are 2 different approaches for VTOL aircraft. One is what's called separately lift the truss, where you have separate devices for vertical flight and for horizontal flight, and the vector thrust, where you use the same propulsors, but you turn them in space. And we are belonging to the later class, and we technically a tilt wing aircraft, meaning our propellers attached rigidly to the whole wing structure. But unlike a classic tilt wing, our wing swivels or rotates around the dihedral hinge, which gives us three advantages at the same time. First of all, it does geometry transformation necessary for change of the vector of that thrust from vertical to horizontal, which you have to have. Well, second, it makes the aircraft is very compact when it hovers or when it's stored on the ground, and we effectively do not pay any weight penalty to do that. It happens automatically, right? Mm-hmm. So it's just like a bird folds its wings and can walk on the ground. And number three, because we have this transformation which goes through a very high dihedral angle before it opens up, the angle of attack of the wing is very mild. It's actually less than 20 degrees. So our wing never stalls. And that is a problem with the classic tilt wing design, because there are some certain angles of transition where the wing fully stalled and creates very nasty dynamics on the landing, right? So we avoid that. And it's all happening just because we use that dihedral hinge, which some people call it the Grumman hinge, but it's actually been invented even before. You can find online the examples of that even earlier.
So the hinge is really the key on the design of this, which allows you to go from that to that, correct?
Correct. The geometry of that hinge is a key. To have it robust enough and to have it rigid enough is a key. And that we spend a lot of time to prove to ourselves and again to the rest of the world that it is actually a viable design.
So Val, what about in difficult meteorological conditions, like let's say you're in the desert and it's 60 degrees Celsius, or you're in Antarctica and it's minus 30 degrees? How have you tested this in that kind of environment, or what are your predictions?
No, we have not really tested it except for the winters of Boston and Boston temperatures in the winter and summer, but I do not see any particular issues with respect to very cold temperatures or very hot temperatures on this design.
What about precipitation? So lots of rain, for example.
Yeah, I don't nothing really there that would make it stop. The hinge itself does experience a lot of stress because all the forces are concentrated in a fairly small amount of space. But with modern materials, it is not a problem.
So what contingency system have you put in place if that hinge suddenly fails? Have you got a parachute on this thing? I mean, because obviously when you go through certification, you know, the agency that's going to be certifying, whether it's the FAA or EASA or whatever, they're going to be thinking, okay, how many different ways can this thing fail? And when it fails, what contingency plan is there in the design?
Right. It's a little bit in the future for us to actually build in full contingency mode, whether it's a parachute or whether it's some sort of solid boosters that will stop the fall at near zero altitudes. But those are all devices could be used. There is nothing specifically that prevents us from putting a ballistic parachute or some other measures like some sort of airbags to stop and soften the fall. And in terms of robustness of the hinge, we use a very simple system. We use a linear screw drive that pulls both wings at the same time. Even if the motor on that screw stops, the aircraft is still completely flyable. The good property of our design, it is stable in any configuration of the wing. So even if there is a failure of the articulation mechanism, you can continue to fly. You will not be able to maybe vertically land it, but you can fly to the nearest airport and do an emergency landing there.
Okay, so you would land conventionally then with the wings.
That's right. That's right.
Okay, that makes sense.
Always a partial wing opens, right?
Yeah. Now you're starting with a version like a drone, and then you're going to develop that into passenger transport. So with the drone version, how soon do you think you're going to come to market, and what are the benefits of this drone? I mean, how much cargo can it carry? What's the speed? What's the range? cost as well?
Sure.
Have you got any numbers?
Our cargo version are still in development. We are working, but all our tests points out that we will have a very nice payload fraction. In other way, if I look at our empty fractions, it's below 50%, which is excellent for a VTOL aircraft, and probably in line what's the best VTOL designers out there report right now. In other words, we can put the same fraction, allocate the same fraction to battery, or decide to put more payload as the best manufacturers out there. But what makes us better in a way that our wing can have a better lift to drag ratio, because it could be very slim and long, and it doesn't, that long wing will not prevent us from being very maneuverable on the ground. So our early simulation shows that we can handle much stronger wing and turbulence when we're landing versus the aircraft that has the wings spread out.
Okay, so what kind of payload are we talking about with the drone?
So the payload could be, like, reasonable payload could be anywhere between 10 and 40% of the aircraft weight, right? So let's say if you want to carry 50-pound payload for a fairly short distance, you probably want to do at least 200-pound weight of the aircraft. Again, so we're talking about fractions here. It scales up to very large size. If you want to go to 10,000-pound aircraft, it will be able to carry anywhere 2,000 to 3,000 pounds of payload. Now, if you want to do a long range, you probably want to reduce the payload to less, to let's say call it 10%, and put the rest of weight of the usable weight into battery system to extend your range.
So is this going to be a hybrid, or is this just electric?
It's very good. It's a very good question. It could be both. The battery only version is easier to manufacture and easier to start with. It also provides economical advantages of being cheaper. But for environment where, let's say, you need 1,000-mile range, we can build a hybrid system that will fly that far.
Okay, and so what are you looking to customize this? So based off the client, if a client comes to you and says, I need 10 of these, and this is the kind of mission profile,
exactly right.
We'll build it to their specifications. What about certification, or is this just going to be a customized, I don't know, experimental drone? I mean, how are you going to go about certifying it for specific clients?
I'll let Matthew answer that.
Yeah, so I mean, there's this is the big question that everybody's facing, and the path to certification for these aircraft, and when I say these aircraft, it really depends on what you're talking about, because there's a large market opportunity for smaller aircraft that are doing Part 107 type flights that are the equivalent in EASA, so 55 pounds or 25 kilograms gross weight, max gross weight.
Yeah.
But that doesn't really become the key restriction, right? Because up until now, most drones just haven't been able to fly very far. So flying beyond visual line of sight hasn't been the big constraint. So even if we have a Part 107 compliant aircraft that does not require certification per se, for an operator to go and fly at 100 miles, beyond visual line of sight in an autonomous way, that's going to require, either a COA, some sort of a waiver from the FAA or the other regulatory agencies internationally. The reality is to get a vehicle certified, and I'm not talking about air taxis, just like, a 100-pound vehicle certified is a phenomenally expensive and time-consuming endeavor, and really is not done at the smaller scale. So one of the reasons that we're working heavily with military applications as well is because some of those rules are different, and they have their own path to certification, and a whole different sort of need, like providing geopolitical advantage and saving people's lives and that kind of thing. So I think that our story and our answer to that question is the same as anybody's. Joby Aviation just went public 2 days ago. I would say that they are by far the leaders in that process, and the progress they've made for the vehicles they're doing has been phenomenal. We're happy to let other companies kind of push that rock up the hill, because that takes a tremendous dedication of resource and time, and and they're doing that for everybody. So we don't want to be the tip of that spear and sort of making that our effort. And that's why we've paced our operational strategy to introduce products into the marketplace when the market is ready for it. Regulation is a key factor there, but there are other key things like public acceptance, noise, for some missions, battery technology, less of an issue for us, battery energy densities, but also just infrastructure. Just imagine, all of these
the whole urban
Right.
mobility thing. People are not realizing that you're not going to allow hundreds of these things to be flying in a city. I mean, okay, we'll use the helicopter air corridors to start with, but
Right.
you can't have hundreds of these things flying.
Right.
There's got to be some form of control, because as soon as one of these things bashes against the building and kills 5 people, they're going to shut the whole thing down. So, I see it in remote locations initially, at least, until we get the technology right, where it's safe enough to operate hundreds of these inside a city.
Right.
And as you said before, the infrastructure is in place.
So the theme of our business is to pace the introduction of our products into the markets as they evolve over time, and can be done within our control. So we're in control of our own destiny, and we're not waiting for things to happen on the outside. The other thing is as Val mentioned, the capability of having high payload weight fractions and long ranges. I mean, that's kind of the secret sauce here, and the stability in its takeoff and landing configuration, and its wind tolerance and turbulence tolerance, and that is really key. So that's our theme. And then we're also going after high value payloads. So I don't really think that the right market initially is to go after, Amazon deliveries of deodorant, when there's already a platform to do that. So we're looking at higher value payloads. And even when you think about air taxis, so air taxis is transporting humans. And right now they're competing against a market that pays about 60 cents per passenger mile. That's the cost of owning and operating a car.
Well,
and if
the interesting thing about that, and because not many people know this number, do you know the average, the high net worth individuals that fly on private jets, okay? The average wealth of one of those individuals that's flying on a private jet is 9 times more than a person flying first class on Emirates, for example.
Right. Fantastic. So, but if you want to have a mass solution that's going to work, it's got to work for everybody if you're talking about that kind of mass transport. But if you just think about human transport, if you contrast, an air taxi that's trying to get to a unit metric of $6 per mile, which will be a challenge at best, and even that's still 10x what the conventional solution is. If you just flip that and you say, well, what about like medevac air helicopters? So there are 550,000 of these trips every year in the United States, and the per mile costs there are between $250 and $700 per mile. So like if you're going to go into a market and enter so that's what we're doing. Not that we're doing medevac. I don't want to misstate what we're doing, but we're going after high value missions.
Diamonds, flying diamonds, gold.
Well, or like a part that an
Technology.
industrial plant needs, a bearing, business to business kinds of things, medical logistics, those kinds of things. Delivering something to an oil rig out at sea, delivering something to a oil tanker. These oil tankers, they come into shore and they have to pass paperwork before they can land, and those things are delivered via these hot shot boats, and it's a very challenging situation. And so there's some of those use cases and that people aren't really talking about, and not that I'm hearing about, but that is
We're looking at coming in below that $250 per cost per mile, basically.
Well, we don't have an air taxi or a passenger occupant platform that's active. Like we're not building a human transport vehicle right now.
So you're aiming, so cargo is your main thing right now.
That's right. Cargo is, and we're pacing ourselves to get there, and we'll be there when the market is there. But we don't want to be leading that charge because there's a lot of work and money that has to be spent that benefits everybody. And I'd rather let other companies bring the whole market forward under their own steam, and then when it's there, we'll be able to take advantage. And that's it. The market opportunity won't be there until that happens. So I want to be there when the market opportunity is there.
Yeah, I mean, I was talking to a gentleman the other day who was telling me about a friend of his who owns a gold mine down in Congo, and he was saying that they transport the gold from the mine to the port on motorcycles. And these
Mhm.
guys put 30 kilos of gold in a backpack with a machine gun, and they drive through the jungle, and they use the machine gun between. They have to, because it's either I kill them or they kill me. So
we have been approached by a diamond company, on the African continent, and so I mean, I know that there's a use case there, there's a business case and a need for it. So
yeah, it's going to be interesting. So going now into more detail with your cargo drone that you're doing here, how soon are we going to see these on the market, do you think? How soon are you? I mean, have you got any idea of how long it's going to take you to get the first one sold, and how much are they going to cost, and what configuration are we going to see initially, do you think? Is it going to be large, small quantities, but valuable, as you're saying, like maybe 30 kilos, 20 kilos?
Right. Well, as Val mentioned, we've got a number of different iterations of aircraft sizes and models. VTOLs up, VTOLs down, vertical stabilizer, like different sizes, lengths of wings, aspect ratios. Like we've done a lot of that, ranging from 4-foot wingspans up to a little over 12-foot wingspans.
Okay.
So and we're working with 2 different flight computers, and so we're really kind of in a productization phase right now and perfecting the different designs. The first aircraft that we will be delivering to a customer that we've signed a contract with, or one that I can mention specifically, I can't give you the details, but that'll be in June of next year. So that will, and I can't give you any more details on that, but that's really kind of what we're focusing on right now. But that's a hardcore standard kind of
Is that just
cargo vehicle.
One?
No, it's several. So
several. Oh, that's good.
Yeah. So
congratulations.
Thank you. And that's in that case, that'll be about a 14-foot wingspan, 80-pound gross weight, carrying 15-pound payloads, all electric. So it's beyond 55 pounds, but for this customer, it doesn't matter. And but the first product that we're going to go to market with is a 55-pound max gross weight, so 107 compliant aircraft that can carry a 15-pound payload. And that, in terms of pricing, this is really important to understand about our aircraft. When you look at our aircraft, there's nothing particularly exotic about it from a manufacturing standpoint and from a cost of manufacturing standpoint. We're using conventional materials, conventional components, all the batteries and everything, the motors, the rotors, and they're custom designed in a lot of cases with these designs with us. But there's nothing that makes our aircraft more expensive to manufacture than another aircraft. The key additional elements are the wing joints and the articulation mechanism, which is not a complicated or expensive element in the manufacturing process. So when we talk about our cost, which is really what drives the price, is that the cost will be what any other manufacturer that gets to scale will be. So at lower volumes, we'll have higher cost and have to have higher prices at higher scale. So it's really about that volume. One thing that we are exploring right now is a different way of bringing the products to market with our customers, and really partnering more with our customers and having an ongoing invested interest in their business over time and align our interests. And that would be reflected in the way that we charge for our aircraft. So we don't have, maybe a long way of saying we don't have a specific price to share with you, but there's no reason why our cost would be any higher than anybody else manufacturing aircraft of a similar size.
So is this going to be autonomously flown, or is it going to be remotely flown?
They'll be autonomously flown. I mean, all of these missions require to achieve the real benefits or the full opportunity of the potential of these missions is to not have a pilot actively flying. And frankly, a computer and sensors with on board can do a really better job. So the technologies surrounding autonomous flight, real-time deconfliction, and all of those components, even dynamic landing on a moving surface, they're moving so quickly, they're doing so well. We'll be incorporating those technologies into our aircraft. So these flights will be autonomous.
So it's almost like, so you stick the cargo on it, you punch in the latitude and longitude where it needs to go, and press the
Mhm.
button, and off it goes, and it lands on its
That's
own,
right.
and then it flies back to base afterwards.
Yeah. And even when you're just putting the cargo on board, which we're even automating that. So we'll have a rig with the aircraft on there. When you put the cargo in, it's looking at the weights and the balance and the center of gravity, and it's sort of like a go, no go. So it's dead simple to allow an operator to do that. And we want the operators, for them to be more technicians than having to be pilots per se, or you know, we're trying to take all of the good lessons that we've learned in aviation, not us, but the whole industry, and to build that into the technology and incorporating the flight computer and the flight controls and whatnot.
Okay, good. So if anybody watching wants to know more and get in contact with you, I guess we'll be posting here your website, so they can come straight there and book a call with you guys. So basically what we're doing is, anybody out there that needs to transport cargo in a remote area, small quantities, maybe of high value, like diamonds, as you said, this is an ideal thing, and you will customize the drone for them, and you build it according to their specifications. So your approach is, the way I understand it, is more of a customized approach instead of building 200 of the same thing. I
should clarify the part of the point, which is that what we're doing right now, we're spending a lot of time learning from different industries, learning what different people who are doing things in this, you know, right now, what their needs are and what is the art of the possible. And we're taking all of that and saying, okay, how do we distill that down into an efficient product line, so we don't have to do you know, custom aircraft, everything. Okay. We don't want to, you know, we don't want every aircraft design to be a bespoke design.
So you want to have maybe 2 or 3 different models.
That's right.
What 2 or 3 models are going to be, you still don't know, because it's based on demand and need.
Right. Exactly. So when, to the extent we're doing customization, we're learning from different industries, and then we're customizing our fixed designs for those things. But that being said, like you said, you know, people that want to come and talk to us who are watching this right now, the opportunities for this industry are just incredible, you know, measured in numbers that just don't even make sense. And I can't imagine in my head, and you know, who knows if no one knows whether they're going to be real until the future, but we know that the opportunities are profound. So we're not trying to do this alone. We are very much a business partnering focused enterprise, and we want to partner with other manufacturers, other technology providers, service providers. You know, we're looking to how do we bring what we think is a really important innovation that's going to benefit mankind to the biggest audience in the right way. And so we can do that a lot faster by partnering with companies. So if people are you know, listening to this and they're saying, gee, this is something that, you know, instead of just thinking about buying our aircraft, let's do a joint venture, let's do a partnership, let's do a licensing agreement. Like, you know, we're all about that, and that's how we're going to be able to bring this to the most people in the best way.
Well, I mean, certainly your Transwing technology enables you to go further and faster than the competition. You know, people that buy private jets because it saves them time. So if you're managing to solve a problem, is getting, you know, diamonds from the mine to the port without being poached in between in the jungle with a guy on the motorcycle, and you can fly it there at the fraction of the cost of a helicopter. You know, you're getting there quick, you're getting there efficiently. Carbon footprint, if it's all electric, is 0. So, you know, you're ticking all those boxes, as long as you can get the cost of operating or buying this thing and operating it low enough to make sense, which my understanding is that you're getting like everybody else in the industry. I mean, I think the battery technology is going to be the challenge, and so there'll probably be hybrid is probably the initial way to go. And then as the batteries improve, then over the next 10 years will probably be all electric, 300-mile range at 300 miles an hour kind of thing.
You know, the important thing to keep in mind too is that as all those things improve, battery energy densities increase, we introduce, you know, hydrogen fuel cells or whatever new technologies, you know, silicon-based battery technology, whatever that is, we will still, we believe, have that advantage, because as the energy that's available on board is added, we still have kind of that advantage. And for your readers in particular, one thing we hadn't talked about is different propulsor options. Right now, our aircraft have rotors and, you know, electric, you know, props, but you know, we've talked with customers about you know, jet engine, you know, versions. Val, if you want to talk about anything about what our views are on that, and what the what the potentials are there. But we could put other propulsor platforms. They don't have to be just electric rotors.
So it'd be like the F-35, you know, or the Harrier jump jet.
Yes, we can do that configuration. We can be very fast. It all depends on what particular mission will require.
Yeah, yeah, it's very interesting, very interesting. Matthew and Val, thank you very much for all this information. And you know, people have watched the footage of your Transwing technology. Very interesting, very innovative. Certainly, you've got a unique selling proposition there up against the competition. And I like the fact that you're having this step-by-step approach. You're starting with small loads, cargo, unmanned, to then eventually get to the passenger version as the technology evolves over time. And your plan is not, it's not, you know, fixed as some are. You're very flexible. And I think that's important in today, because technology is changing very quickly. And we all know about Moore's law and, you know, the exponential growth and change and whatnot that's happening in technology today. And a lot of people don't realize this. I mean, I was talking to some people that have this big airport project in Canada, and I won't say which airport it is, but they have this big plan of developing this third runway, and the amount of money that's going to cost to develop this third runway. And they have two options, either south of the current runway or over the water. And I said to them, well, I don't know how much this plan costs you, because you must have paid these consultants a lot of money. What they haven't considered is the development and technological advancements of aircraft. Because I said to them, by 2032, which is your plan, most airplanes will be taking off and landing vertically. I said, and you know, and don't take my word for it. Go and see what Elon Musk is doing, because everybody thinks SpaceX is going to the moon and Mars. But what they don't realize is one of the projects is to go from anywhere to anywhere in less than an hour with a rocket. Now, don't get me wrong, you can't fly everybody on a rocket because people have heart problems. They won't be able to go on a rocket. But I certainly see in the next 5 years, Elon Musk is going to start to fly 500, 600,000 kilo, 5,000 kilos worth of cargo from San Francisco to Shanghai on a rocket. And it's going to take 35 minutes to get there. And the rocket gets to the other end. It's reusable. It flies back again with another load of cargo. And as soon as you have 5, 6, 7, 8, 9, 10 stations around the world that can do this, and they're doing it with cargo and they're quite happy the way it's going, the next step is to fly human beings. So, you know, we've got all this coming in the next 10 years. And some of the airport people just don't realize that, you know, wait a minute, because technology is changing, and it's changing a lot quicker than it used to. And so, you know, if you are developing something in the technology space like you guys are, you have to have a plan, but not too detailed, because guess what? In 3 years' time, the battery technology has changed. Now you can get a lot more mileage out of a small battery.
Right.
So we know that there's electric circuits today which were that big, and now they fit in the palm of a hand. I mean, think of the technology on a cell phone today. There's more technology in this than there was in the Apollo 11 that went to the moon.
Sure. Yep.
All true.
I know. Yep. Yeah.
So amazing times ahead. So good luck with everything, Matthew and Val and Patera Dynamics. And those of you that haven't subscribed yet to BizJet TV, I encourage you to subscribe to this channel. Comment below. Let's get the chatter going. What do you think about the eVTOL market? What do you think of this fantastic Transwing design? And let's get the conversation going, and give us a thumbs up. And that's all from us here at BizJet TV, and see you on the next one.
Thanks. Bye.
Thank you very much.
Okay, so I'll stop the recording.